When I started my career as a coral reef researcher, we were doing this experiment where basically we had to go a little bit deeper and deeper. We had to go down to 40 meters for 10 minutes and do photosynthesis measurements. And we had to do this dive day after day. While I was sitting on the reef slope, I was always kind of gazing out in the distance. And at the very end of it, I could make out this coral community. Too deep for scuba diving. And every day I found myself wondering what was in the distance. For me, that really set the scene in wanting to go and explore these deeper reef communities. And that's the Mesophotic zone.
Wow! Oh my God, look.
It's a zone that's very poorly studied. And so it's very much a frontier of reef ecology. So the Mesophotic zone is kind of a transition zone between the shallow reef and the deep sea. Between 30 meters and 150 meters depth. Mesophotic coral ecosystems occupy vast areas of the ocean floor. And they harbor very rich biodiversity, yet we know very little about them. It's only really in the last 10 years that tools have been developed that make this zone more accessible and that we can actually study these communities.
As a team of scientists, we've intentionally tried to pick places where we can make the most difference. On these expeditions, in various locations, we are exploring and understanding these deep reefs from a multidisciplinary perspective. So we have oceanography, biodiversity surveys, and coral reef biology.
Coral itself is the building block of an entire ecosystem. And what is important for us is to try and understand how these function.
On one hand, we're interested in studying the zone to see to what extent shallow reef organisms can actually extend down and maybe find protection against some disturbances. On the other hand, every time we're exploring these depths, we're also finding species that are unique to this zone.
Zooming out from just coral itself, there are so many different other components, like we have sponges and we have macroalgae, and all of them together kind of create a certain structural complexity that then becomes a home for different fish.
Tropical coral reefs are one of the most biodiverse habitats that we have on our planet, that communities have been interacting with for a long period of time. Mesophotic reefs have always been part of the fabric which makes up these coastal communities. But one of the really interesting things is the stark differences in the upper shallow zones relative to the lower Mesophotic.
The lower Mesophotic zone, you've got a real turnover of spooky fish, and it's dark down there, and it's like a complete switch.
It seems as though there's completely different processes operating on how it is that those communities come to be the way they are.
Sweet. We'll do a couple of these. The ocean is always on the move. It's mixing and transporting heat, nutrients, and carbon from deep to shallow.
Okay.
You got it.
Okay, number 12.
Physical processes is actually the underlying phenomenon that is going to influence how an ecosystem can survive or degrade over time.
There's some thinking around mesophotic reefs being able to provide resilience for both shallow ecosystems and tropical environments in warming years or marine heat waves.
Coral bleaching, for example, which is really pronounced in the shallow, has lesser impact at depth. And so we're wondering about whether these communities might act as refuges for certain species.
We're currently in the UN Decade of Oceans, and being able to do this research at this time is really an opportunity to showcase some of the less known ecosystems within our planet to people making decisions that impact the rest of the population on Earth.
Awesome. We've just been seeing our first reef building corals here. So it's really important that we get an idea of what kind of genus of coral it is. We're really trying to get an understanding of what drives these Mesophotic communities and why are they so variable.
There are some similarities when we go to new sites, but actually each of these places that we go and explore is slightly different.
Whether you zoom in and see all these different components of the reef, or you zoom out and you look at a bigger level, we always have more questions that we want to answer.
It's a real frontier of exploration.
3, 2, 1, go.
And so we're continuously developing new tools. And finding new ways to explore these deeper reefs and learn more about them, which is extremely exciting.
It's discovery science, so to speak. We've got some objectives, but we're not quite sure what we're going to find.